Okay, here's an explanation of our practice quiz for Unit 2. We have a couple questions on here related to this position time graph and then some general motion questions where we will probably be using formulas. So, practice quiz, let's take a look at this graph. It's a 50-yard dash. And we have position in yards versus time. And it looks like there's 3 runners, Susanna, Leo, and Ashley. So we have the diamond, the square, and the triangle. Okay. Who runs the same speed the entire time? Who runs the same speed the entire time? So speed or velocity from a position time graph is slope. So if we take a look at, let's say, Leo's graph, his graph goes like this and goes like this. So he was going some speed here, he had some slope, and then right here you see how the slope changes and the slope decreases. Steep, not as steep. So Leo went fast and then went slower. Similarly, Ashley had some slope, and then you see right here how the slope changes. So she was running some speed, and then right there at about 5 seconds picked up her pace and started increasing her speed. Susanna is running from the 50 back to the 0 for some reason. Okay, so she's running the other way at the same time that these two start from 0. But do you notice how she has this constant slope? It's a negative slope, so she's running backwards, but she has a constant speed. So our answer to question number 1 would be that Susanna has a constant speed the entire time. Who finished their run first? So they're all running 50 yards, and both Leo and Ashley finish at 12 seconds. Susanna, however, finished her run at 10 seconds. Looks like she won the race even though she was running the opposite direction. Maybe it was downhill or something. Who finished the run first? So, Susanna. Okay. And who starts out, so this is question 3, who starts out fast then slows down? Meaning their slope is steep and then their slope decreases. So that is this graph. Steep and then not as steep, so starts out fast and then slows down. So that was Leo. When do Susanna and Leo pass each other? So Susanna is this line and Leo is the box or the square. So they're going to pass each other, meaning they have the same position at the same time. So that would be right here. Okay, they pass each other, and that looks like something like that. So I would guess 3.5 seconds. And so for, rounding and whatever, you're not going to get marked off for that. But let's take a look, see if we can be really precise. Somewhere I have an arrow tool. Oh, a line tool, even better. So let's see. Oops. Niet. Okay, that's definitely not working. Never mind. So anyway, 3.5 seconds looks pretty good. Question 5, approximately how many meters apart are Ashley and Leo at t equals 4 seconds? Ashley and Leo at t equals 4 seconds. So here is Ashley and here is Leo. So what we're looking at is we trace those values over to the position axis to look at how far apart they are. So it looks like, I'd say 33 would be Leo's position, and something like 8 would be Ashley's position. So if you got something like 25 meters, yards, apart, that would be great. And so this right here, aha, that's a typo. Shame on me. Question 6. What was Susanna's average velocity? Alright, so what's the difference between average velocity and average speed? So speed is just the magnitude, the amount of how fast they're going, whereas velocity is a vector quantity. It depends on direction. So when we talk about average speed, it's actually the total distance divided by the total time. However, when we're talking about average velocity, it is the displacement. Displacement over the total time. So by displacement, we mean the difference between where they started and where they ended up. So it is possible to start in some location and move forward and then move backward and have a displacement and therefore average velocity of 0. Okay, so that was a little review. What's the question asking? What was Susanna's average velocity? So she doesn't go one direction and then turn around. So she goes from 50 to 0. Okay, so that's her, well, that's where she started, that's where she ended up, and that's over the course of 10 seconds. So if we were to do this, all right, displacement would be final minus initial position, and we're going to divide that by time. Looks like we get -5, and this would be yards per second or meters per second if the graph were in meters, which it was supposed to be but isn't. Okay. 7. At which of the following times do Leo and Ashley have the same speed? Alright, do Leo and Ashley have the same speed? So Leo and Ashley, the square and the triangle, if you look at this, if you look at this region and this region, looks like their slopes are the same. Okay, so between here and here, here the slopes are different, and then here the slopes are different. But if we take a look at between here and here, the slopes look the same. So that might be, this looks like 3 seconds, and hey, that looks like 5 seconds. So those would be the times where Leo and Ashley have the same speed, because their position time graphs have the same slope. So between 3 and 5 seconds. So we could say between 3 and 5 seconds. Sorry about this messy writing. 8. Which of the following times are Leo and Ashley farthest apart? This sounds like it was a multiple choice quiz and I erased the answers. At which, what are we looking at? At which of the following times are Leo and Ashley farthest apart? Oh, well, it kind of looks like the same thing here. So here's Ashley and here's Leo. So farthest apart meaning the distance between these two lines. They start in the same place, they end up in the same place, but between here and here they are farthest apart. Interesting. So our answer here would also be between 3 and 5 seconds. Okay, next, what was Leo's average speed? Leo's average speed. So, he was going fast and then kind of slow. Alright. So, what was his average speed? We want total distance. He went 50 yards divided by total time, 12 seconds. So, this is his average speed. His speed was fast and then slow. But for the average, you look at the total distance he went and the time that it took him. So we're going to say Leo's average speed, we have total distance over total time. I'm sorry, that is not meters. I need to change this. And then 50 divided by 12 is, who knows, where's that calculator? Great. Here's that calculator. 50 divided by 12. Yeah, 4.17. Alright, 4.17, and that would be yards per second. Ooh, what was that? And lastly, question 10, what event occurred at t equals 3 seconds? So let's take a look at 3 seconds. Aha! What event occurred? So at 3 seconds, something happened, and that is that this graph, and this looks like Leo, changed his speed. So right here, nothing really happened with Susanna, nothing really happened with Ashley, but Leo basically slowed down at t equals 3 seconds. So what event occurred at t equals 3 seconds? We could say Leo slowed down. And let's see if there's anything else. It's pretty close to where Susanna and Leo pass each other, but that was more right around here at 3.5 seconds. So okay, that looks like the event. Next up, we have these two questions. I wonder if I could get this thing out of here. Ooh, cool. All right. A car travels at a constant velocity, so we're looking at number 11. This is kind of a free response. Car travels at a constant velocity of 30 meters per second for 1 minute and then slows down to a stop over the course of 10 seconds. How far did it go in total? All right, so we have two situations here. It's going, if we were looking at a velocity time graph, for me this is helpful. So it goes 30 meters per second for an entire minute. And then it slows down to a stop over the course of 10 seconds. So that's 10 seconds right here, and this, a minute, is 60 seconds. And its velocity would be 30 meters per second. So I'm sort of not really drawing units because I'm out of space, but you know what I mean. So when we're looking for how far did it go in total, we're looking for the distance traveled, for this and for this. You may recall that the distance traveled is the area under a velocity time graph. So I'm going to take that shortcut right now, and then we'll calculate using a formula. If I were doing area, I have a rectangle, and that is 30 times 60. And I have a triangle, which is plus 1/2 base times height, which would be 30. And doing these calculations, it looks like we would get 1,800 and 150. So I'm putting my money on 1,950 meters. But let's see. Okay, so finding distance, let's plug into some formulas. Okay. For the first region, we have, they're moving at a constant velocity. So this is simply, if they're moving at a constant velocity, or even if you know their average velocity, distance is velocity times time. So distance for the first region would be their velocity, which is 30, times their time, which is 60. For the second period of time, or region, they are slowing down, so there is some acceleration. So we are going to use our formula of the month, which is, so the final position is 1/2 acceleration times time squared plus initial velocity times time plus initial position. Let's call the initial position 0, okay, because we're just looking at how far they travel in that period of time. So we could say that the distance is 1/2 their acceleration times time squared plus initial velocity. I am running out of space, which is 30 times time plus initial position. Now, notice how I left that acceleration blank, because we need to think about that. For their acceleration, they went from a speed of 30 to a speed of 0 over the course of 10 seconds. How much velocity did they lose every second? Well, the answer is 3. But if that's not making sense, we could always do this. We could calculate acceleration from change in velocity over change. Oops, I'm out of time. Dang. I'll come back.